Hello and welcome to this video on the role of gluten in bread. This is a topic of growing interest as the gluten-free market is one of the fastest growing food sectors. This makes it a very valuable market to be selling into if possible, and many products that make a lack of gluten their key defining feature are now available. Many times this is an excuse used for food that tastes like cardboard. Since gluten has been found in so many foods and has been taken out of an increasing list of foods, what is gluten? At its simplest, gluten is a protein. That by itself is not an especially helpful description. Primarily, gluten's composed of two types of proteins which together come under the umbrella of gluten, these being the glutenins and gliadins. Depending on how you look at this, you can define these a further variety of ways. The most common and simplest to use is whether or not they have a high or low molecular weight. The second and perhaps more commonly used way of defining these is whether or not they are alpha, beta, gamma, or omega gliadins. These particular proteins they occur in nature as a means of protecting seeds when they're in storage. This means that the seed has a nice, neat coating around it which will keep everything it needs contained until it's ready to sprout. When you take the two proteins together, they are what are defined as gluten. Taking away one or the other will generally make it rather mute, as they're no longer a gluten. Whilst primarily wheat and barley are going to have what we know as gluten, just about all other common grains do as well, whether that's corn, oats, and so on. The notable difference between these glutens and the glutens found in things like rice is that they don't cause a reaction for those with celiac disease, which is primarily an immunological condition. Let's start looking at the details of each particular protein that makes up gluten. Gluten's main protein is glutenin. This makes up about 47% of the total content of protein within things that have a protein content that we consider gluten. They are nearly high molecular mass, and then there are some smaller subunits. The smaller subunits are considered low molecular mass. The two parts work together, and they'll range in length from between 200,000 to several million units in that length. Obviously, with such a large structure, it needs to be stabilized, or the two parts will begin to separate, and that'll cause problems with denaturation of the protein. The primary means by doing this are your disulfide bonds and hydrophobic interactions. Disulfide bonds being sulfur bonds between two parts that are like a stitch that hold them together. Hydrophobic is more or less those sections of the protein are trying to hide from water and as such are forced together that way. Gliadin is the other product that we're going to look at here. It's the second protein that makes up gluten. There are three subtypes, and for the purposes of this video, we can simply say that there are three. Each of these is defined by their varying amino acid sequences. For the most part, your alpha-beta gliadins have relatively low solubility in low percentage alcohols, and this is the easiest way to measure for them. Gamma gliadins are slightly different again, and the way you look for these is not so much based on the way you can dissolve them in something else, but rather the number of disulfide bridges that are made within it. This is also the area in which the lesser proportion of protein is present. You need both glutenin and gliadin to create gluten. Without this, gluten does not exist. Gluten is important and is developed in the dough when the proteins begin to take up water and it gets bound up within it. This is useful, as some of those bonds we've mentioned are based on hydrophobic forces. Others rely on disulfide bonds, which can be broken in a water-rich environment. The mechanical movement of kneading dough helps to force the various parts of your flour or wheat to be in contact with the water and mix everything thoroughly. The kneading process ensures all proteins come in contact with water, and this turns them into long, flexible strands that have been worked out so there aren't as many kinks and knots. This turns it into a sort of net or mesh. As the yeast produces CO2, it turns the dough into something similar to a sponge. The sponge has many bubbles within it, and the net that is the gluten helps to trap these pockets of gas. The dough and the consequential gluten within it will expand and stretch. When you then proceed to cook your dough in the oven and turn it from dough into bread, those strands will coagulate and solidify. This is exactly the same phenomena you'll see with, say, browning on steak, cooking of eggs, clotting of blood, and so on. The solidification or coagulation of the gluten provides structure, and as it solidifies, it traps the gas within the loaf. That gives you a nice, fluffy loaf of bread, and that also provides that structure, the stretch, when you bite down and chew. Of course, water is not the only thing the gluten will interact with, and this is important in the context of breads that use things like butter, milk, cream, and so on. When you add lipids or fats, they're going to interfere with the gluten. The more lipids there are, the more likely it is the gluten will be unable to form those necessary mesh bonds. That is because at a fundamental level, the gluten is broken up into shorter sections by the lipids. This prevents those long chains, and rather than getting one large net, you get many smaller sections. This is why biscuits and cakes tend to crumble rather than stretch when baked, even though they both have gluten in them. So far, we've looked at two applications: the normal use of gluten in bread, and to be clear, you can add extra gluten to improve bread, and it is sometimes sold as bread improver. You can also look at interfering with gluten function. This is particularly useful if you're trying to create something that doesn't have that same solid structure. There's also foods in which you need more protein, and specifically gluten, than you would for bread. Pasta is an exact example of this. Gluten is needed to give pasta a firm texture, especially when cooked. If you were not to provide that firm texture when it was cooking via gluten, it would simply fall into a stodgy mess and lose all structural integrity. This is why certain flours are recommended, because they have a high gluten content. In other cases, foods are made by taking the gluten out of existing flour. This is done by washing away the other content. This leaves only behind the protein component and can be turned into a sort of quasi-meat product or meat substitute, which has high protein content. On the other side of this equation, you might want to look at having a low protein content. These are flours that are often described as weak or soft. They have up to 8% protein by mass. By contrast, bread flours are considered strong and have up to 14% protein by mass. These are distinctions that are important when you are looking at the role of gluten. Remembering that gluten makes up the vast majority of the protein within bread. Using bread as an example, as you leave bread to proof, carbon dioxide is produced. This occurs in the largest amounts in the final proofing stage. If you don't have enough gluten within your bread, you're going to find that the gases expanding during this process cause the bread to break, and when it breaks, the gas will escape. This causes your bread to collapse and you lose that light, airy texture. Gluten provides the elastic power needed to hold it open even as those bubbles expand. This is one common issue that occurs when low-protein bread is used. It's called overproofing, and the bread simply exceeds its elastic strength, breaks, and the gas is released. Hopefully you can now see how important gluten is for bread. In fact, how important gluten is for most grain-derived foods. Without gluten, food can taste bad, and as a result, they are often loaded with sugars, fat, or salt to make up for this bad flavor. That in itself may solve the flavor issue, but nothing will take away the texture and mouthfeel of gluten-free cardboard, and in many cases, cardboard may be more palatable than gluten-free options. Thank you for watching this video. If you all found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.